I like how this is for just.
Okay, this should be really brief. I mean, this is stuff that I almost don't even probably need to review. Let's just go over a few of the basics, just so we can remember what some of the conventions are. This assignment isn't even up yet. It should be, I'll put it up tonight, okay, so you can get working on it. It'll be very short. On the handout I gave you, so we're just gonna go through the notes and you can fill the notes in, and then there's 3 questions that I want you to do. They've got boxes around them. I think it's 5, 7, and what? 9. I just wanna see you do 3 of these. And so when I'm done, the first thing I want you to do is try those out, and then I've got the solutions up here, so just come up and check the solutions and just tell me, if you get them, give me the thumbs up. If you have a question on something, go up to see me. I just want to verify you can get through a few of these before you jump into the assignment. Okay, but no big deal. So graphing inequalities. Remind me what we do for this. We use a blank dot for which kinds of symbols. So let's say we use an open dot for which kinds of inequality symbols?
Less than or equal to.
Less than. Do I include an equal sign? No, I don't. Good. For either less than or greater than. Okay. I'd use I guess I got that backwards, didn't I? That should have been, I got my grammar wrong. Oh well. We use a closed dot for what? What's the difference?
Less than.
Okay. And that's easy to remember. It takes more ink to draw a closed dot. It takes more ink to include an equal sign. And so that's including the endpoints of intervals, right? Okay? So interval notation. Have you used interval notation before? Brackets and parentheses and things like that to represent intervals? Okay, maybe not. Okay, we'll look at that. So here's the simple rule. So interval notation is a way to write the solution to an inequality. And really what it means is you're writing an interval of values of x, right? Or y, or whatever we're talking about, usually x. We use infinity symbols, and we use parentheses, and we use brackets. So parentheses indicate not included, and so parentheses would fall into this category up here. If we have parentheses around an interval, that's equivalent to, using an inequality, that would be equivalent to using a regular inequality with no equal sign, or an open endpoint, okay? If we use brackets, brackets take a little more ink to draw than parentheses, and so they go with closed endpoints and including the equal sign with the inequalities, okay? So for example, and you know this, how could we, if we wanted to graph the inequality x is greater than or equal to 8, how would I do that? Where's my endpoint? At 8. Okay, so if I make this 8, and that's 9, and that's 7, how am I going to graph it?
Closed dot on the 8.
Closed dot on the 8.
And then a line to the right.
Okay, and I'm extending, not a line, what would I call that?
Array.
Array. Extend array to the right, so it goes forever, right? How would I say that using interval notation? Okay, I'm going to need a closed bracket, and this is a little different. We're going to use a closed bracket. 8 is the endpoint, and how do you suppose I say it goes forever in the positive direction?
Infinity.
Infinity. Think what that says. That includes all the values from 8, including 8, up to infinity. In other words, x is greater than or equal to 8. Now, what kind of a symbol would I have to use around the infinity? Could I use a bracket, or does it make any difference? Bracket or a parentheses? What's singular for parentheses? Parenthesis, I suppose? I don't know. Which one? Is it rounded or square? Or does it matter? Doesn't matter. It could go either way. So let's think about the implications. If I use a square one, what's that mean?
It could be equal to.
I'm including infinity, right? Okay, does that sound right? That doesn't sound right, does it? Is infinity a number? No, it's not. It's just a concept, right? Infinity just means limitless or big without bound. So I really can't do that, because that seems to imply that I can get to infinity. But if I think I've gotten to infinity, how much further do I actually have to go?
Infinity.
Right? So I can't use that kind of an enclosure when I'm talking about having infinity representing the end of an interval. It has to be a rounded bracket, because we can't ever include infinity. It would be wrong to make that a square bracket, okay? How about this one? What if we say a is less than -1? Where's my endpoint? Okay, so that's -2, -1, and 0. What kind of endpoint am I drawing? Open? Which way am I going? Left. So how do you suppose I would say that using inequality notation, or interval notation?
Parentheses, -1.
I'm hearing -1.
Negative would be.
Okay, yeah, no, so where's, okay, so that, yeah, that wouldn't make sense, would it? Right? That's saying x is, that implies that negative infinity is bigger than -1. We gotta go back a little bit, right? Because you notice that this is just like a number line. The 8 is to the left of infinity. So that's the way it shows up in our interval notation, right? So over here, negative infinity is to the left of -1. I have to have a rounded bracket next to the infinity because I can't include it to the negative infinity. What about the -1 this time?
Still parentheses.
Okay, it's gonna be rounded too, isn't it? Because I'm not including the -1. Okay? Make sense? All right, so that might be a little bit new. We'll go through a couple examples like that. So, solving inequalities. Just quick reminder. We follow the same rules to solve an inequality as we do to solve an equation with a few exceptions. Now, the only exceptions you guys have probably ever talked about. Let's click those Chromebooks all the way close, please. What's the only exception you've probably ever talked about? The only one we'll probably use. Maybe, well, probably this year. Might use another one later. But same as solving an equation, except what? What's different about solving an inequality?
Do you change the sign when you multiply or divide by?
Okay, if I multiply or divide by a negative, I have to flip the inequality, right? Okay, so let's try a couple quick examples. And this is just, this is no big deal. So if I want to solve this for x, we're going to go about thinking this process in virtually the same way we would treat an equation, right? Solving a multi-step equation, I've got multiple x's here. So what's my thinking? And I know this seems excessive to think about the process for doing stuff like this, because algebra is not that hard, but this is just a model for what we do with later, harder stuff too. So what's our thinking here? If I've got multiple x's, what do I have to do? Okay, I got to distribute and combine because I'm simplifying, right? Remember, I'm going to work down order of operations. I'm going to simplify until I have a single variable, and then I can reverse my order of operations to isolate the variable, right? So that involves two things here. We just have to distribute the -3. What's that give me?
Negative 15 minus 27.
Okay? And then, let's see, we end up with, what, 6x. If I add the 27 to the other side, 34, good. I never had to flip the inequality sign because I never multiplied or divided by a negative, right? So last step, divide by +6, so once again, I don't flip anything. So I get the answer I get the answer x is greater than or equal to, what can I reduce 34/6 to? 17/3. Okay? So that's our answer, and when I post the assignment, there's going to be a variety of different kinds of problems. Some of the problems I'm going to want you to answer using inequalities, okay? Some of them I'm going to want you to answer using interval notation, so you're used to both. So there's my answer using an inequality. How would I write that using interval notation? Brackets. Where's my endpoint?
17.
17/3. So what integers would that be between?
18/3.
5 and 6. Okay, so if we did, there's 5 and there's 6. So that looks pretty good right there, doesn't it? About 17/3. Okay, which way Close or, I made it close, is that correct? Okay, good. Am I going to the left or the right from there? There it is, okay. Interval notation. Bracket. Okay, good. And the bracket is on the left because I have a left endpoint here, don't I? Right? And then it extends to infinity and beyond. Okay. All right. How about this? Yep.
Distribute the negative and like this and simplify.
Okay. So distribute the negative. We're going to collect like terms. So 3 minus 4m minus 1. Got to distribute the negative 1. Greater than or equal to 5m minus 25. Now what?
Combine the 1 and 3.
Okay, so 3 minus 1, 2. Okay, push the variables where? To the right. Okay. And if I push, I could go either way, but if I push them to the left, when I'm dealing with inequalities, why is that especially dangerous? Because I got a negative coefficient, and that's going to force me to divide by a negative, and I got to remember to flip the inequality, right? So it's even more important when you're working with inequalities to push the variables to the side where they're positive. It works either way, of course. All right, so plus 4m. If the variables are going to the right, where do the numbers go? Another direction. So we get, what, 9m on the right side, and what do we get over here? 27. And so what can I do to simplify? Divide by 9. Okay. So I'm going to get 3 on this side. Now that's correct, but that's an awkward way of writing it. How should I probably change that answer? Flip it the other way, yeah. Instead of saying 3 is greater than or equal to m, we'd want to write that as m is less than or equal to 3. Okay? And then that just means if this is 3, solid circle to the left, right? And my notation would be what? Okay. 3 bracket. Good. All right, so I'm going to make a couple up here. I want you to try this one for me. Actually, I'll pull some off. I have some of these built. I just don't have them all built. So let's try this one. Oh, where is that? There we go. Let's try this. Oh, darn it. Okay, what about a problem like this? Now, this time, the instructions say solve the inequality, write your answer using interval notation. Okay? So there's a few specific things here. Now, this won't come up until we start dealing with compound inequalities, which will be tomorrow or the next day. This union symbol. We might have to deal with this, though. If we're using inequality notation and we get no solution. If the answer is no solution, there are no real numbers that make this true, then the way we deal with that is we just enter the empty set symbol, which you grab it on the pi drop-down menu on Google. Okay. So that's our set notation for meaning no solution. Okay, what about this one? What do we gotta do? Distribute, so if I distribute the 4, I get what, 48x plus 16 is greater than,
48x minus 160.
okay,
Cancel.
what can I do? Okay, I can subtract 48x from both sides, right? So the variables drop away and I'm left with the inequality, 16 is greater than negative 160. How do we interpret that? That's true, isn't it? How often is that true? All day long, right? That's true always. So what do you think our answer is? All real numbers, right? So the answer is all reals. But we're asked to enter this using interval notation. So there's a special way to write all real numbers using interval notation. What do you think that might be?
Parentheses.
Negative infinity. Positive infinity.
That's it. That's how we write all real numbers using interval notation. Everything clear from negative infinity to positive infinity, which is everything.
Every number.
Okay, and we know that using interval notation, how would we have gotten an answer where there might have been no solution?
It was all.
60 is greater than 60.
Okay, if we got something like, if we had this reversed, what if our answer had been instead that? That's false, right?
Yeah.
So if that's false, that would mean we'd have to use the empty symbol, right? Empty set symbol. Okay? What if we were solving this using inequality notation? Well, if we're using inequality notation, we get the same answer. We get 16 is greater than negative 160. On those ones, the instructions would just say enter an n if there's no solution. Just enter a capital N. And if it's all reals, just enter a capital R. Okay? So you got to read the directions, because this is kind of something that's specific to interval notation, right? Okay, I think that's it. I think you're good. Try those 3 problems. Come on up and check them. Give me the thumbs up. And after that, you can work on whatever you need to work on.